So here we are with Chapter 5, problem number 28, another friction problem. It says a stubborn 120 kilogram mule sits down and refuses to move. To drag the mule to the barn, the exasperated farmer ties a rope around the mule and pulls with his maximum force of 800 newtons. The coefficients of friction between the mule and the ground are mu sub s is equal to 0.8 and mu sub k is equal to 0.5. Is the farmer able to move the mule? So I've got my free body diagram here showing that when the mule is hanging out, doesn't want to go anywhere, the farmer is going to apply his maximum force of about 800 newtons. And this friction force of the static type is trying to work against it so that the mule cannot move. So I'm going to write the givens down. I know that the mass of the mule is 120 kilograms. I know that the farmer is going to apply his maximum 800 newtons. And they tell us that the coefficient of static friction is 0.8 and the coefficient of kinetic friction is 0.5. And they would like to know, will he move? So if he's going to move, if the mule's going to go somewhere, the farmer's going to be able to put him wherever he wants to put him, he's going to need to overcome that static frictional force. So that's the first thing we should investigate is the amount of force that the farmer applies, that 800 newtons, is that going to be enough force to break that static friction? So what we want to know is what is the maximum amount of static friction that can be applied to the mule? Remember that static friction, it will increase or it'll match an applied force up until some maximum amount. And once you break that maximum amount of static friction, it then turns over to kinetic friction when it starts to move. But if you stay below that maximum force number, that maximum static force number, it will just match whatever is applied to it. So the number that we're going to find, it's the maximum amount. It's not the actual amount that the farmer is going to apply. We can talk about that after. So to find out what that frictional force is, I'm going to say that the static friction force is equal to mu sub s times the normal force. And the normal force, as we can see here, is just equal to the weight because the mule is just hanging out. So we know that we've got 0.8 is the coefficient of static friction. We know the normal force is going to be equal to 120 mass times gravity, which is 10. And we find that the coefficient of static friction is going to be 960 newtons. So this means the farmer can pull and pull and pull. He can go get some equipment, he can go get some friends, and as long as they do not pull with more than 960 newtons, that mule is going to stay in place. So we talked a couple minutes ago that the static friction will change to match whatever you're applying as long as it is below its maximum amount. So in this case, the static friction can apply up to 960 newtons, but because the farmer is applying 800 newtons, the static friction is also matching that in the opposite direction of 800 newtons. So that's number 28.